With its flexible materials and shader system, Leadwerks Engine can support any number of cloud layers. Now this is a good example of the design philosophy behind this engine, because I could have added a create cloud layer command, and I guess I would have needed another command to specify how many cloud layers there should be, and I would have needed another command to control the speed of the cloud layers, and I would have needed another command to control the direction they move in, and someone out there would still not be happy with my implementation of how I thought it should work. Rather than try to hard-code every little feature the user might want, we've tried to design a system that's flexible enough that you should be able to add anything you want. And here we're going to show how it's possible to add a new feature to the engine without having to modify the source code. I've created a new pixel shader here, and I've called that cloudlayer.frag. And if you're familiar with GLSL, you can get an idea of what this does. This is just going to take a number of texture samples and blend them together and animate them with the AppTime uniform value. And then I've created this, actually that's the cloud material. This is the cloud layer material. And this uses the regular mesh vertex shader together with the cloud layer pixel shader. And it gives it an alpha blend, and it uses the cloud layer.dds texture, which is here. Here's where we created our skybox. So I'm going to create a cloud layer rendered on top of that. I'll just call this clouds, and I'm going to use a sphere for this. And I'll invert the sphere because the camera will be inside it. And notice I'm creating this sphere right after the background world is created, so the sphere will be an inhabitant of the background world. Then I'll paint this sphere with the cloud layer material. And I'm going to stretch the sphere out a little bit. I'm going to make it a little bit short. So let's run the program now. And now we can see our cloud layers moving overhead. And this pixel shader is rendering 4 layers, but it's very easy to change. And you can see if I had added a command to create cloud layers, it might be fun at first, but you would get bored with it pretty quickly and it would be very limited. By designing a flexible system like this, you can really implement cloud layers in any way you want, and we can control the speed, we can control the direction, and it doesn't require oversight from me, and I don't have to alter the main engine source code to do this. We can create volumetric clouds using a particle emitter, and for this part of the tutorial I've copied this code straight from the article. And we have this create cloud function, and this will create a particle emitter with properties that make it act like a cloud. And then if we go down to this loop here, this is going to create 10 different volumetric clouds and position them randomly around the scene. Now you'll notice I'm creating this foreground world, and I'm going to create the clouds in this foreground world, and I'm going to render the foreground after the sky is rendered and after the main scene is rendered. So of course I have to create another camera for the foreground world, and I'm going to set the clear mode to 0 because I don't want it to render the depth or the color buffer. And then down here I'm going to first render the background, and then I'll render the main world, and then I will render lighting with the render lights command. Then I'm going to set the world to the foreground world, update the world because we have particle emitters in that world, and then I'm going to position and rotate the foreground camera to match the main camera, and then I'll call render world. Now if we wait a few moments, we'll see these volumetric clouds appearing as the particle emitters cycle. So you can see it wouldn't really make sense for me to add a cloud class to the engine when the particle emitter system is flexible enough that if you want a cloud, you just decide how a cloud acts and create an emitter that acts that way. The system is flexible enough that you could use the emitters for weather effects, like you could create an emitter that follows the camera around and simulates a dust storm, or you could use it for rain or snow or whatever you want.